All right. Our lesson today is on solving for the x-intercepts of a quadratic function in vertex form. For our current unit, this is learning target 4A. Now the good news about this is that we have spent a lot of time doing this exact type of problem throughout the year, right? So the majority of this lesson, if not all of this lesson, will be review for many of you. All right, so this is a good opportunity to kind of solidify any of those solving skills that maybe weren't quite as strong as you want in first semester. So let's talk about a couple of specific things, just as reminders to make sure we're all on the same page. All right. So, as I mentioned, we've done this before. We've talked about our three possibilities when solving, all right, a quadratic function. All right. So we said earlier that we could have two solutions, one solution, or no solutions. Now the transition we're going to make is now talking about, okay, now specifically we're talking about intercepts. So instead of just referring to them as general solutions, we're going to talk about them as x-intercepts. All right, as well, but they imply the same thing. All right, but when we see the word x-intercept instead of solution, what we're saying is that our function was set equal to 0. Because remember what we've already discussed is that all x-intercepts, all right, have a y value of 0. So that's typically the difference. Is sometimes you might say solutions, but that may not be specifically referring to when y is 0, depending on the problem or the setup. So what we're going to do now is just talk about those three things, and I'm going to give you a visual here so you can see. All right, we know really there's two cases when we talk about quadratics. They can open up, which are our three guys here at the top, or our quadratic could open down. So if you look here, here's an example of a quadratic that opens up with two x-intercepts. Here's an example of a quadratic that opens up with 1. And basically, if you have one solution, what that means is that the vertex is the x-intercept. All right. So what that means is that one of your important points is really a 2-for-1 deal here. So we have an x-intercept and a vertex. So very important there. And then you can see here's one that sits above the x-axis. It opens up, so it will never cross here. And then you can see kind of the same thing here with our 3 that open down. So here's one that opens down with 2 x-intercepts. Here's one that opens down with 1 x-intercept. And once again, in that case, that's always the vertex as well. And then here we have one that opens down, all right, and no x-intercepts. All right, so what we're going to do now is just go through some review problems, some example problems, all right, to kind of make sure we're all on the same page with our mechanics as far as solving. All right, so I'm going to do 4 problems with you here to kind of refresh everything, and then I'll give you a chance, all right, to work some of these on your own. All right, so looking at our first example. All right, so we're looking for x-intercepts, and what we know is every x-intercept, y is 0. So that's the first thing we're going to do to start the problem is plug 0 in for y. Now remember when we saw we were reversing our order of operations, so the first thing I want to do is undo this addition or subtraction here. So I'm going to add 12 to both sides. Okay. Then I'm going to undo the multiplication or division associated with our variable here. So I'm going to divide by 3. All right. So that's 4, and that equals x squared. And the final thing we're going to do here is take the square root to undo the square. Now the big key here is, remember, when we take a square root, there are 2 answers. Okay, we have 2 times 2 is 4, and we have negative 2 times negative 2 is 4. So there are 2 solutions, which imply we have 2 x-intercepts. We have negative 2, 0, and 2, 0. All right, so now let's look at this one. Once again, the first thing we're going to start with is plugging 0 in for y, because we are specifically looking for an x-intercept. All right, now I'm going to add 5 to both sides here. Okay, so 5 equals negative 5x squared. All right, I'm going to divide by the constant here, which is negative 5, and that's going to give me negative 1 equals x squared. All right, now I'm going to take the square root. Boop! Whoa, hey, now, hey, got to keep this in mind. All right, can't take the square root of a negative. Now, if you do this on your calculator, you're going to get an error. You're going to get something on your calculator that says you can't do this. Listen to that. Okay, so what this is telling us is that there's no solution. We can't take the square root. I should say no real solution. We can't take the square root of this negative number. So what this applies for us, and I want you to specifically say this, is that there are no x-intercepts. All right, and then that way I know that you can interpret this and you know, all right, the meaning of what's happening here. All right, so let's look at, all right, a couple more examples. All right, okay, now once again, we're looking for x-intercepts. We know x-intercepts are an x value y value is 0. Alright, so let's plug in our 0 for y here. So we have x squared divided by 4 minus 3. Once again, I'm going to undo this part of the problem first. I'm going to add 3 to both sides. 3 equals x squared divided by 4. Now, once again, we're undoing this. Alright, so the way I'm going to undo dividing by 4 is to multiply both sides by 4. And I get 12 here. So x squared is equal to 12. Now, so what some of you may notice right away, all right, when you look at this is you know we're going to take the square root. Now, some of you, all right, are much better at recognizing perfect squares and such. So what happens now is, all right, I'm going to take the square root of 12. All right, and like I said, some of you may recognize this, that it is not a perfect square. All right, so you're going to have to take the square root on your calculator, and what you get here is 3.46, and that's okay. Once again, not all of our x-intercepts are going to be nice, pretty integer-only answers, okay? So very okay that you get a decimal here, and then once again, we're going to have the negative square root as well. All right, so those would be our two x-intercepts. And once again, we are always going to go back and finish the problem by writing them as points. All right, x-intercepts are points. We want to get in a good habit of that. All right, last one for now that I'm going to do with you. All right, and this one's really, really quite simple. All right, so once again, we're going to start by plugging 0 in. All right. Now notice there's no extra constant out here, so I can go right to dividing by 4. So I get 0 equals x squared. I take the square root, and there's only one number times itself that will be 0, and that is 0 times 0. So this is an example of only having one x-intercept. In this case, it's going to be 0, 0, okay, which is the origin. All right, so there are 4 examples for you, all right, so that I've done for you. So what I would like you to do now is take your time. I want you to pause the video, and I would like you to find the x-intercepts of these 3 quadratic functions. When you're finished, turn it back on, and we'll see how you did. All right, my friends, so hopefully you've wrapped that up. So let's take a look. And so what I've done is I went ahead and just kind of typed everything out. That way you could see the steps, all right, of the problem. Okay, so on our first problem here, you can see that you plug 0 in, we subtract 1, okay, we multiply by 5, and we get x squared equals negative 5. Now, once again, if you try to take the square root of a negative, okay, on your calculator, all right, or if you just recognize that, that's not something that we can do, so we have no x-intercepts for this problem. Okay, this is one of our simpler problems, so we plug 0 in. We don't have to worry about an extra constant out here, so we can divide both sides by negative 6. We get x squared is 0. We take the square root of both sides, and we get 0. So this is, once again, an example of our one x-intercept, which is 0, 0. So that also is the vertex. I mentioned that earlier. All right, and then you can see the last example. Plug 0 in for y, add 18 to both sides, divide by 2, take the square root, we get plus or minus 3. So those are our 2 x-intercepts, and once again, get in a habit, write these as points. So 3, 0, and negative 3, 0. Okay, so now, let's take a look at, all right, a little bit more complicated. So we're still in vertex form, all right, still in vertex form. We're still, okay, looking for our x-intercepts, all right, okay. So we're still know it's going to be something 0. Now, what we have talked about, so I'm going to go ahead and write this first step out here. All right. Here we go. Okay, and so we've talked about this, that when I have this exponent, all right, on the outside of my parentheses, that these parentheses are locked. I cannot distribute into them. So what we have to do is basically follow the first 2 steps of this problem, just as if it were like the prior problems we did. So the first thing I'm going to do is try to take care of my extra constant, whether that's before or after the parentheses. So I'm going to add 50 in this case, all right, to both sides. So I have 50 equals negative 2 times x minus 3 squared. Then I'm going to take care of the constant in front of our parentheses. So I'm going to divide by negative 2 here, and I get negative 25. So your goal is to isolate the parenthesis. So we want to undo everything else and isolate this parenthesis so that we can now undo the exponent by taking the square root of both sides of our equation. Now, once again, we're taking the square root of a negative number, which we can't do. So what we know is that there are no x-intercepts, all right, for this particular quadratic function. All right, so this was a problem that some of you struggled with first semester. So just remember, if I see the exponent on our parenthesis here, it's locked. I cannot distribute into it. So I have to isolate it. All right, so let's look at this example. All right, now, when we see this, once again, I'm starting with the 0 here. All right. Okay, once again, our parentheses are locked. I cannot distribute into them, so I want to isolate them. So I'm going to take care of the extra constants that added or subtracted. Okay. So we get to this guy. I'm going to take care of the constant that's attached, whether that's by multiplication or division. So in this case, I'm going to divide by 3 since we have multiplication. All right, now here is where you have to be really good. All right, so now we have a positive number. I can take the square root of that positive number. Now what we know is that there are two solutions. I'm going to have 1 and -1. Now that's going to be equal to whatever is inside of our parentheses. So x plus 1 and x plus 1 here. All right, now what this means is if we have more than x being squared, we just have additional steps to solve. And we just follow our regular rules. So I'm going to treat this like an individual problem and subtract 1 from both sides. So I get 0 is equal to x, which means one x-intercept is 0, 0. I'm going to come over here and subtract 1 from both sides. So I get -2 is equal to x. So my second x-intercept is -2, 0. So it's very important that you realize that you have to branch off and create, right, your two pieces here to represent the two solutions from completing or taking the square root. All right, let me do two more examples with you before you try some on your own. All right, so once again, we're looking for an x-intercept. So it's going to be x, comma 0. So I'm going to plug 0 in. All right. Now, once again, I see my parentheses are locked. So I'm going to try to clear everything else away first. I'm going to subtract 30, subtract 30. So I get -30 equals 6, x minus 7 squared. Then I'm going to clear this off. All right. I get -5. All right, so I'm going to square root it, square root it. Once again, I'm taking the square root of a negative, so hopefully you're hearing that in the back of your brain saying, no way, can't do that. All right, so x-intercepts, there are none. Okay, and that's probably not real good grammar, so let's say there are no x-intercepts. All right, so one final example before I set you off on your own here. All right, so I'm going to plug 0 in for y. All right. Once again, my parentheses are locked, so I'm going to clear everything else. There's no extra constants added or subtracted, so I'm going to go right to clearing off the constant that's right here by dividing by -5. Okay, I take the square root. Now, I can take the square root of 0. There's nothing wrong with that, but that means there's only one answer, which is 0, and that has to equal to x plus 5. So I subtract 5 from both sides. All right, -5 is equal to x. So my x-intercept is -5, 0. Now, remember, if we only have one x-intercept, that is also your vertex. All right, my friends. So here are 3 examples for you to complete on your own. All right, so once again, go ahead and pause the video, complete all 3 problems, and then turn it back on, and we'll see how you did. All right, so once again, I've kind of outlined everything here for you so you can see the work and kind of check it. So as we go through the first problem, we plug 0 in, we subtract 7. All right, we divide by 7, and then once again, we take the square root here. We get the square root of -1, which we can't do, so there are no x-intercepts. All right, our problem 2, we plug 0 in for y. Okay, once again, we don't have an extra constant out here. All right, is that the exact same problem I just did? Oh, it is. Bonus time. Hopefully you got that really good there. I think I wanted to put a different number in here, but hey, that happens sometimes, right? One x-intercept. All right, and if we look at the third example here, plug 0 in. Okay, we have to add 24. We have to divide by 8. Now, once again, this is a positive number. I take the square root of that positive number. So I get 2 answers, plus or minus 1.73. All right, so I have to have 1.73 equals x minus 2. Negative 1.3 equals x minus 2. I add 2 here. All right, and just so in case that's a little confusing, I put those are a little tight there on my slide, but these are 2 separate problems. So oops, let me try that again here. So just show you see that is, these are 2 separate guys here, okay? So add 2 here, 3.73, add 2 here, 0.27. So there are our two x-intercepts. So the big idea is this. If this number is positive, right before you take the square root, you have to set up your two branches to represent the positive solution or the positive root and the negative root, and then solve from there. All right, so to wrap things up, okay, just two final problems here. All right, a linear problem and an absolute value problem. And once again, it's the same type of stuff. I just wanted you to see some of these because you're going to have some in your homework. Anytime we're looking for an x-intercept, we plug 0 in for y. All right, doesn't matter the type of function. All right, that's what we're always going to do. Now, I did this on purpose because I wanted you to see the difference here. Is notice we have parentheses, but they are not locked. We are not raising the parentheses to a power. So what that means is I can distribute whatever's in front to both terms inside here. So negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. And then I have the minus 2. So I can combine like terms here. So I have the minus 17. I can then add that negative 17 to both sides. So 17 is equal to 3x. Divide by 3. Screw it out just a little bit here. All right, so I get 6. No, hold on. I do not get 6. I get 5 and 2/3 here. So you might get 5.67 if you do that on your calculator. All right, so you have one x-intercept. There we go. Now the good news is we treat this problem just like we looked at, all right, for our quadratics. Okay, so what we've discussed in class is that our absolute value bars, we consider those locked as well. So we want to isolate those and then set up our two equations. So the first thing I'm going to do is, okay, add or subtract that extra constant, whether it's in the beginning or the end. All right, we get to this guy. I'm then going to clear any constants attached or divided by here. So I'm going to divide by 5 on both sides. So I get to this statement. Now, once again, the possibilities for the x-intercepts of an absolute value are the same for a quadratic. All right, so what this tells me is I'm going to have two solutions, all right? Because we know there are two numbers that have an absolute value of 5. We have 5 and negative 5. Those are the two numbers that are 5 units from 0. So 5 could equal to x minus 5. Negative 5 could equal to x minus 5. And then we would, okay, solve these like regular problems. So there's one x-intercept. And then if I add 5 over here, all right, I get that. And there's our second x-intercept. All right, so there you go. So there's our review of, all right, x-intercepts. So now you should be ready to complete the homework. All right, which is worksheet unit 6.5. You need to be prepared and you need to make sure you are paying attention because there are, while our unit is mainly on quadratic functions, all right, I've thrown in some linear functions and some absolute value functions just so that we review those concepts as well. All right, so once again, just bring to class your notes, any questions you have over the example problems or the content from the lesson, and then be ready to jump into that homework assignment. See you then.